Hi and Assalamualaikum. My name is Alia Diana. My metric number 076612, representing Group 1, would like to present about online quiz student. Let's go through our system architecture very quick because after this I will explain more in the next slide. First, we got 4 students, Alice, Imran, Haris and Diana. These 4 students will submitted their answer, and a hash function is applied to each answer and generate a key. Hash function will pass to the distributed hash table. The distributed hash table will assign each data, that means each answer, to a specific node. So we got 3 nodes, node 1, node 2 and node 3. When the data need to be retrieved, the output will be displayed in the console output. Next, system design, how the communication work. First, student as client retrieve or request files. This refers to a client server model where student acts as client. Next, we have node student. Nodes is a data that's stored in a system. So based on our system architecture, there are node 1, node 2 and node 3. Node also is responsible for handling certain pieces of data based on hashing. Next, student. Student is a end user where we call client that can request or retrieve data or files. Naming structure. This structure follow DNS hierarchical format, making it human readable, easy to organize and scalable for different types of user. Okay, let's see. Student will represent the type of user and will be declared as unique identifier, which is names. Next, the organization domain will be referred as their uni. Therefore, when the student store their data, it will be formatted as entity name, identifier and domain. Name resolution, strategy used and the importance. How it works. First, we have 4 students, for user provided their answer, and this answer will pass through the hashing function to generate a unique key that we call hash value. This key is used to determine which node, either node 1, node 2 or node 3, responsible for storing the data. Then, when a query is made, for example, finding Alice's answer, the hash of Alice will recalculated through the DHT to locate the appropriate node. For the importance of naming resolution, scalability, where the DHT enables the system to scale efficiently by distributing data across multiple nodes. For fault tolerance, this means if one node goes down, the system can still resolve by names via other nodes. Data replication strategy. What is exactly happen? After the data is hashed and assigned to a node, it will likely be replicated to other nodes. For example, if a piece of data originally mapped to node 2, it will likely be replicated to node 1 and node 3. This is to ensure availability. This is what I said about availability. Even if a node fails or leave the network, the data remains accessible from its replicates. For load balancing, multiple copies can reduce the load of a single node when multiple users request the same data. Let's look back at our full system design diagram. This is the result of our system. Let's go through each part by part. First, distributed data storage. Each student answer is stored on different nodes using a distributed hash function. Example, Diana's answer node 1, Haris answer node 2, Imran's answer node 1, and Alice's answer node 2. Why Imran answer is stored in node 1? This was because we used the line of random choice nodes. What is this mean? This means the system randomly pick a node for Imran hash name. Next, data replication. The system shows 3 replications successful. This ensures that even if one node fails, the data can still be retrieved. Why Imran's result delayed? This because the system either retrieve Imran's data late or experience slower processing on nodes 1. Next, evaluate correct answer. After the data is stored and replicated, the system will evaluate the right answer. For the key takeaways, we have learned that data handling efficiently, where it consistent hashing ensure predictable data placement. The data is evenly distributed across nodes and quick access through deterministic key-based routing. The system are responsive with independently and boost real-time data collection and processing. Architectural flexibility, where it enables easy integration of new nodes, and flat structure avoids hierarchy and simplifying maintenance. What can we put to improve the enhancement of the system? First, we can introduce the data caching for frequently accessed input, or add encryption or access control for secure data handling.